So activity from chapter 18, 19, and 21. Like I said, this is the most important material from the unit. But what we are going to see is 10. Come on. Why do you not let me try this again. There we go. So we are going to have 10 multiple choice questions and 2 free response questions. So that's what the test is going to look like next week. So 10 multiple choice, 2 free response questions. And I will tell you that the 2 free response questions are going to be taken from 18, 19, and 21, meaning make sure you can do a confidence interval for 1 proportion and for 2 proportion. Make sure you can do a significance test for 1 proportion and 2 proportion. Now, there's only 2 free response questions, so you're not going to have all 4 of those in the free response, but you will have 2 out of those 4 things. So the 4 things are the 1 proportion, the interval, the 1 proportion, z-test, and then the 2 proportion, z-interval, and the 2 proportion, z-test. So the 2 free response questions will be chosen from those main ideas there, which is basically what this whole unit has been about. And remember that if you are doing a confidence interval, whether it's for 1 or 2, we panic. We define our parameter. Okay? If there's 2 proportions, then you have 2 proportions to define here. You check your assumptions and conditions. If you have 2 proportions, you got to make sure that you check it for both samples, because 2 proportion would mean you have 2 different samples that you're looking at. Name the interval. So 1 proportion Z interval or 2 proportion Z interval. I know it's only 1 here because this was before we did 2. Set up your interval, give it, and then interpret it. Okay, in context. So those are the steps for any kind of confidence interval. You are doing a hypothesis test. And yeah, 2 free response. I bet you there will be 1 of each. 1 interval, 1 test. A hypothesis test or a significance test. Phantoms, define your parameter. If it's a 2 proportion hypothesis test, there will be 2 parameters. You can call them P1 and P2, or you can call them whatever you want. P sub something, P sub, I mean, don't call them W or something. I mean, it's a proportion, call it P something. Okay, set up your null and alternative hypotheses, whether it's 1 proportion or 2, you still need hypotheses. Check your assumptions and conditions. Slightly different for the 2 proportion because we pool our 2 proportions together to check our conditions for the large counts. So hopefully you can look that up on your notes and remember that. Name your test. 1 proportion z-test, 2 proportion z-test. Which one is it? Give a test statistic, a z-score, and a p-value. Observe, is your p-value larger or smaller than your significance level? Based on that, make a decision. Do you reject the null or fail to reject the null? And then state your conclusion in context about whether you have convincing evidence of something, okay? So how do you tell which one it is? Let's look at this. A stats professor asked her students whether or not they were registered to vote. In a sample of 50 of her students, randomly sampled from her 700 students, 35 said that they were registered to vote. Number 1, find a 95% confidence interval for the true proportion of the professor's students who were registered to vote. So first off, is this a confidence interval or a test? Yes, if it's an interval, it will be very clear and it will tell you to do a confidence interval. So if you are asked or expected to do a confidence interval, it will tell you. It has to tell you, make a confidence interval. So we know that this is a confidence interval. It's not a test, it's a confidence interval. So the next question is, How many proportions is it? 1 or 2? So if you read this problem, how many samples are we looking at here? Just one. She just takes one sample of 50 from her students. So just on the side here, I'm going to make note, hey, this problem is going to be a one prop Z interval. Except I can write better than that. So just so we know, this is one prop Z int. I'm abbreviating so you can tell. So as you're looking at the free response questions on the test next week, how do I know which one it is? See if it's a confidence interval. It'll tell you if it is. If it's not, it's most likely a test, and you might see something about test a claim or is there convincing evidence of something. That's how you know that it's a test. And then the other question will be, well, how many samples, how many proportions are we looking at? Okay, number 2, explain what 95% confidence means. That's why are we 95% confident? So we'll make sure that you guys know how to do that. What's the probability of your proportion being in your confidence interval? And according to Gallup, 73% of 18 to 29-year-olds said that they're registered to vote. So does this seem reasonable based off of your confidence interval that you created? So you can't answer that till you've created it. And then the last question here is solve for n. In other words, what size sample should we create if we want margin of error to be within 4%? Okay, so this is a, what does n equal if you want the margin of error to be less than or equal to 4%? Within 4% would mean less than or equal to 4%. So what size sample? Now, it does say back in 2004, they knew the information from September 2004. So in other words, they knew about this 73%. So that means feel free to use 73% because it specifies and says they knew that. So you can use 73% to calculate your n that you would need for your margin of error. When they don't have any value to use, the only way to guarantee a margin of error is with 0.5. And we've done that before. Okay. Next page, a report on healthcare says that 28% of Americans have experienced times when they have not been able to afford medical care. A news organization randomly sampled 801 Black Americans, of whom 38% reported that there have been times in the last year when they have not been able to afford medical care. Does this indicate that the problem is more severe among Black Americans? Number 6, test an appropriate hypothesis. Does that clearly tell you what you're doing here? Okay. If it asks you to test a hypothesis, this is a hypothesis test. Do not do a confidence interval here. It's much easier to do a test. And if you look here, we only have one sample. They randomly sampled 801 Black Americans. That's the only sample that we have here. So this would be a one prop Z test. Okay, and you can get your notes out and make sure that you know how to do a one prop Z test. And then questions about it. Did you do upper tail, lower tail? What does your p-value tell you? And then the next one, Great Britain has a great literary tradition that spans centuries. We're talking, Shakespeare, for example. One might assume then that Britons read more than citizens of other countries. Some Canadians, however, feel that a higher percentage of Canadians compared to Britons read. A recent Gallup poll reported 86% out of 1,004 randomly selected Canadians read at least one book in the last year, compared to 81% of 1,009 randomly selected Britons. Do these results confirm a higher reading rate in Canada? Test an appropriate hypothesis. This is a test. How many samples do we have here? 2. There's a sample of Canadians and a sample of Britons. So we're comparing people in Canada with people in Britain. So this is a 2-prop z-test. And number 10, find a 99% confidence interval for the difference. So this is using the same information, but now we're going to be doing a confidence interval. So knowing that this test is going to be on confidence intervals and tests, there's nothing wrong with reading through and making sure that you know which one you are looking at each time. We've only learned 4. So these are the 4 different ways that we have learned to do inference. These 4. Okay? We're going to learn some more in the next unit, but so far we've only done those 4. Okay, so I'm going to have you guys work on this, and I'm going to walk around and help you guys out, especially make sure you're writing out your conditions clearly. I know that it's tempting when you're doing a review sheet kind of thing like this to not, but get in the habit, write out your conditions, do the entire test in the detail that is required when you are being assessed and on the AP exam. Okay, you will lose credit if you don't check your conditions. If you just write your conditions, that's not the same as checking them. Make sure that you actually check them. And then the last 15 minutes of class, oh, we got some more people. I did not hear the little thing here. Last 15 minutes of class, I'm going to go over the sampling distribution quiz because I went over it yesterday with group B, but obviously you guys were not here. So the last 15 minutes of class, I'm going to go over the quiz that we took last week with those of you guys that are here in class. And of course, those of you guys that are online are welcome to stay and listen to it again. But at that point, if you don't feel the need to stay, that's fine. Stay online. It's best just in case something comes up, you're online and listening. And other than that, we are working on this. Online, you will see that there are personal progress checks that are tonight. So personal progress checks, there are 3 of them. So we have this, and we have 3 personal progress checks on AP Classroom. They are excellent multiple choice example problems because you are going to be doing 10 multiple choice questions next week. So do those personal progress checks. Okay, we'll go over them in class tomorrow. And then the only other thing, there's no other assignments this weekend. The only other thing is on Schoology in the folder that says review. There are, I think, 3 different practice tests in there. So please do them, or at least look at them. We're going to post the answer keys. 2 of them are already posted, but I'll make sure that the answer keys to all of those are available to you as well. But if you don't look at them, you're basically, going into the test a little more blind than you need to. The more you know, the more you practice, the more you see example problems and, worked out solutions, the better off you will be. So even though there's technically not going to be homework this weekend, we have a test coming up on Monday and Tuesday. Monday for Group B, Tuesday for Group A. So please use the time that you have to look at as much review as you can. Okay, so let me take roll real quick because I haven't done that for Group A. And then I will walk around and help those of you guys that are here, especially since this is your last time in class before your test on Tuesday. And those of you guys online can stay and ask me if you have questions. I'm going to stop recording though, because I don't think there's... Okay, on the calculator up here, I've got the 1 proportion Z interval. Of course, make sure you have defined your parameter. So we're looking at the proportion of students that this particular teacher or professor has that are registered to vote. So we're trying to estimate the proportion of the students that are registered to vote, and based off of our 35 out of 50 from the sample at 95% confidence, we have an interval that spans between 0.57 and I'll say 0.573 and 0.827. So there is our confidence interval. So I am going to write that down. And also, I did not check my conditions, and you guys are going to. So 0.573.827. Let's see if I remember that. Well, I think I forgot it. 0.573 and 827. Okay, so there's our confidence interval. Again, make sure you define your parameter, which is P is the proportion of the professor's students who are registered to vote. Checking our conditions, we need a random sample so that we have an unbiased estimator, and it says they were randomly sampled. So make sure you write down that that is indeed the case. We are sampling without replacement here, so we need to check our 10% condition. 50 students is less than 10% of all the students. There are 700 students altogether, so that is less than 10%. That's the reason that you were told about the 700 in case you were worried about the 10% condition, but that is met. And then P, or N times P, we don't have a P, but we do have a P hat. 35 out of 50, which is 0.7, can be used as an estimate for P. So N times P and N times 1 minus P, both of those do come out to be greater than or equal to 10. So lastly, when you create your confidence interval, I want to make sure that you know the difference between interpreting your confidence interval. So I'm going to interpret this interval. So this means I am 95% confident that the interval from 0.573 to 0.827 captures, that's what we're trying to do, the true proportion of students who were registered to vote. Registered to vote. Okay, that is different than this, which is explain what 95% confidence means. So interpret the interval is this. I am 95% confident that the interval from here to here captures the true proportion of students that were registered to vote. That's the context. This is really asking, why are we 95% confident? And that has to do with the process. The process of finding a 95% confidence interval is based off of a normal model, which we know that when you go 1.96 standard deviations in either direction, you've got 95% of your values. So that means 95% of confidence intervals that we do this for will capture that true proportion. So why are we 95% confident? So if many confidence intervals are created in this way, so in this way of a 1 prop Z interval using, a random sample of 50 students from her class. So if we did this many times, we expect 95% of them to capture the true proportion of students who were registered to vote. You can finish the sentence there. So the proportion of students who were registered to vote. Now, number 3 is really what I wanted to talk about. Okay. Number 3 says, now that we have all of this, what's the probability that the true proportion of the professor students who are registered to vote is in that confidence interval? In other words, what's the probability that we have captured the true proportion? And this is kind of a trick question, because it is not 95%. So, true proportion, is it in here? Is it possible that it's in here? The true proportion of students that are registered to vote. Is it possible that it's in this interval? Yeah. Is it possible that it's not? Okay. If it is in the interval, the probability is 1. If it's not in the interval, the probability is 0. The problem is we cannot really ask about probability here, because the probability, I mean, it's already been created. It's kind of like if I flip a coin and I ask you, what's the probability that the coin I flipped yesterday is heads or tails? It's either 1 or 0. And unless I tell you what it is, you don't know what it is, but it's not 50% because I already flipped it. I already created the interval. Before I create the interval, I'm creating an interval that has a 95% chance of capturing the true proportion. But once it's created, it either worked or it didn't. So I do not know what the probability is, but it is either 1 or 0. Okay, so either 1 or 0. Okay, so if P is in the interval, the probability is 1, and if P is not in the interval, the probability is 0. Problem is, we have no idea. We're 95% confident that the true proportion has been captured in there, but we really don't know for sure. So we do not know if that true proportion is in there. We're 95% confident that it is, but the probability is either 0 or 1. Okay. Now, you're not normally asked that, but the point of this is make sure you never suggest that, oh, I have this confidence interval. There's a 95% chance that I have captured the true proportion. Because no, either you did or you didn't. Probability is only used to describe the likelihood of future events. Once the interval has been created, we don't talk about probability anymore. Either that interval worked or it didn't. We have 95% confidence in it, but the probability question is pretty much off the table at this point. Okay, so I did want to talk about that, and I wanted to talk about it in the context of actually having our confidence interval. Okay, because this is a really common misconception, the idea of being able to talk about probability when something has already occurred. Okay, so like I said, I flipped a coin yesterday. Chances that it was heads, it's either 0 or 1. Even if I don't tell you what it was, that doesn't change the fact that the probability is either 0 or 1 that it was heads. Okay, it's not 0.5. It happened. It either was heads or it wasn't. Okay, I think I mentioned the probability that it rained in Rockland yesterday is 0. We know that because we were all here, and we know that it didn't rain. However, if I ask that same question to someone, who lives in Europe, what's the probability that it rained in Rockland yesterday? They don't know the answer, but it's still 0 or 1 are the only two choices. They just don't know. They can look it up online, but they don't know. So the idea of not knowing doesn't change that probability. Okay, I'll let you guys keep working. And like I said, I want to go over that sampling distribution quiz. So we'll do that in about 15 minutes or so. About question number 6. It says, can you clarify, is the 28% of Americans and then the 38% of Black Americans, or are the conditions not met? So on this problem here, number 6, we are testing a hypothesis, okay? It says, a report on healthcare says that 28% of Americans have experienced times when they have not been able to afford medical care. We're testing whether the problem is more severe among Black Americans. Okay, so just to set this up, we are interested in the proportion of Black Americans that have not been able to afford health care within the last year. Okay, so that's what we don't know. We don't know what proportion of Black Americans have been unable to afford health care within the last year. We do know that 28% of all Americans have experienced times when they have not been able to afford health care, but we do not know what it is among the Black community. So the 28% represents all Americans. So the question here, is the situation more severe for Black Americans? Okay, if the situation with healthcare is more severe among Black Americans, their proportion would be greater than 0.28. Because for all Americans, it's 28%. If the problem is more severe among the Black community, the proportion of Black Americans that have had trouble affording health care is going to be greater than 0.28, excuse me. The null would be that it's equal to 0.28. In other words, Black Americans have the exact same struggles as all Americans, and the problem is exactly the same, 0.28. Okay? The alternative is that the problem is more severe in the Black community. Okay? So that's our hypothesis. So now when we check our conditions, or when we look at what we have here, N is 801 Black Americans that have been sampled. And it says of that sample, there were 38%. So my p hat is 0.38. Now the X that you'll need, because in your calculator, they ask you for X, I can figure out what X is by multiplying my sample size by 38%, because it was 38% of the sample, which is 304. So X is 304, because 304 divided by 801 is where the 38% comes from. See? 0.3795. They rounded that to 38. That's where the 38 came from. It came from 304 people in the sample said, yes, they have had trouble affording health care within the last year. Now, when we check our conditions, it's going to be about this sample. Is the sample random? Yes, randomly sampled. Is we're sampling without replacement, and there's only one sample here. 801 is less than 10% of all Black Americans. So that is definitely a true statement. And then when we want to check our large counts, we always use P, not P hat, unless we have no value P. But we do have a value P. We have the null hypothesis value. We are assuming that P is 0.28. So when you check your conditions for a test, go to the null hypothesis. If you have a P equals value, which you will for a one proportion test, that's the value you use for checking your large counts. So we're going to take 801, multiply it by P, and then 801 multiply it by 1 minus P, and verify that you get at least 10 on both of those. Okay? And you will, because I mean, I can see that that's definitely going to be at least 10. Okay? So the conditions are going to be met. Okay? So you guys can write all that out and then carry out the test. But it is important to distinguish these two numbers. So that's what we're testing against, all Americans. This is what our sample shows for our sample of African Americans. Okay? So we are testing, is the healthcare situation a more severe problem within the Black community than it is overall for all America? So it kind of sounds like it's two proportion, but it's not, because we did not actually take a second sample. We're just comparing our one sample of Black Americans against our overall proportion that was given. I will put the full answer key to this in my notebook as well, so you guys can look it up. Because I'm going to do it now, because I'm going to struggle at least a little bit. Oh, you're going to have to read it to me. Oh, no, wait. There's a 5B and there's a 6C. Because what happened is the order that College Board does some of the topics was different than the order we did it in. So we skipped 5B earlier because we didn't get there. That's on two proportions and all that. It just has to be the order. So yeah, the progress check is a 5B and then a 6C and D. And it's just because the order that we did some of our topics was slightly different than the order College Board puts them in. So that's why we skipped 5D earlier, because it was dealing with two proportions. And we hadn't done it yet, so that's fine. So it's not a misprint. It's the 5D and then 6C. I'm useless without them. I thought I had them, but I have to read it. Okay. Okay, the sample distribution of the sample proportion. Okay. Oh, one of the following
following is the least value for a sample size that would allow the sample distribution of the sample proportion to be approximately normal. Yeah. The more than 30 is for means. It's for the sample distribution of a sample mean. The NP and the N1 P is for the sampling distribution of a proportion. What kind of sampling distribution is this? No, sample proportion. So you gotta calculate which N would give you an NP. Yeah, basically which one you multiply by 8%. Which of the following must be true for the sampling distribution of the sample be approximately? So again, it's the NP and the yeah, the 10% is not about the normal. The 10% is, can I use this formula from standard deviation? So the random sample allows you to use the mean unbiased. The 10% condition gives us independence, which allows us to calculate standard deviation, and then NP and then 1 minus P allows us to use normal. Yep. Yes, thank you. So, with all the conditions other than that, one's supposed to be good. So, I would check that p-value. This p-value cannot be bigger than 1. P-value is 8%. So, ooh, look at it. So, you know what that p-value is? Basically 0. I mean, it's literally 0.000000000. Yeah, you can, check it's 9 zeros. 10 places or zeros, but I'm okay if you say it's approximately. Teeny tiny p-value. So it is, it's because it's basically the same. So you have a very small p-value and very convincing evidence to reject the null and reject the new. This is Melania. Yeah. The mean of all sample proportions from random samples of 100 data is equal to 0.72. Yes, that would be good. Because Q is right. So A, the random sample of 100 dentists is simple. That's saying if I took a random sample of 100 dentists, I'm going to get 72%. Yes. Because they're sampling variability. Maybe you get 72, maybe you get 71, maybe you get 73, who knows? But the mean of every single possible sample will be 72. Okay, randomly selected Gaussian setting and a Gaussian probability that's both. Okay, again, that's just one randomly selected sample. And this is for all random samples of study 100, the mean of all the possible differences will be simple. Sampling distribution is always the distribution of all possible samples. Right. The distribution of one sample is different than the sampling distribution. Okay, so we had a quick question here on problem number 5. Okay.
So on problem number 5, we are trying to figure out what size sample will give us a margin of error within 4%. So this is one proportion. This is the professor again with trying to figure out what proportion of her students are registered to vote. Margin of error formula is Z star times the standard deviation of P times 1 minus P divided by N. That's the margin of error. We want the margin of error to be within 4%. Now we're doing this with 95% confidence. So 95% confidence gives us a 1.96 value for our Z star. And then this is where I said we can use the P that's here because it says they're aware of the study from September 2004. So we can use that as our best estimate of what we think P will be. In other words, we don't expect it to change too much. We don't know that for sure, but when they give you a value like that, use it. So there's the P, there's the 1 minus P, and N is what we are looking for. So you are now going to use your fancy algebra skills and solve for N. So to do that, divide both sides by 1.9 and then square both sides. That'll get rid of the square root, multiply these two, and then multiply both sides by N because N's in the denominator. And then you need to round up because you will get an answer that N has to be greater than or equal to a number with a decimal. And you can't get greater than or equal to unless you round up. So you will have to say N has to be at least, whatever that is. Okay, you guys want me to finish that or is that? Are we okay with that? Okay. Because that is algebra from there. Okay, so I want to pull up our sampling distribution quiz. So hold on. I'm going to think about where I'm going here. Okay, so we're going to go over the sampling distribution quiz. So I am going to do this. And let's see. I find my sampling distribution quiz. Not there. Where is it? There it is. Okay, and then for online, I gotta share that screen. And there we go. Okay, so our sampling distribution quiz. Get rid of that maybe. No, it won't let me minimize. There we go. So it says, this was the quiz from last week. A recent Gallup poll showed about 37% of Americans said they frequently experience stress in their daily lives. Suppose we take a random sample of 100 Americans. So back over here, it says, what's the probability that no more than 30% of people in the sample will say that they frequently experience stress in their lives? Make sure you identify the sampling distribution and check all your necessary conditions. So what they are saying here is that in a recent poll, 37% of Americans is our entire population, So 37% of all Americans experience some type of stress in their daily lives. Okay? Suppose we take a simple random sample of 100 Americans. So first thing they give us is a value for P, a value for N, and then part A says what's the probability that no more than 30% of people in the sample means we're looking at a P hat. So what's the probability that our P hat is no more than 30%? No more than means less than or equal to 30%. So this is what they are asking us to find. The probability that a sample is taken of size 100 and the sample shows less than 30% of people in the sample are affected by stress in their daily lives. Now it says make sure you identify the sampling distribution and you check all the necessary conditions. So conditions, we have randomization. And on this quiz, the biggest issue we had was not checking all of our conditions. It said SRS, so sample is a simple random sample. So you got to check it. You got to say, yes, we were told we have a simple random sample. Okay, why is that important? That gives us a mean value of 0.37. In other words, I can use that as my mean. In other words, that's a unbiased estimator with a mean of 0.37. Okay, second thing is since we are sampling without replacement, we need independence. Independence is also the 10% condition. So independence, 10% condition. And we've got N equals 100 is less than 10% of all Americans. Our population is Americans because it started off by saying 37% of Americans frequently experience stress. This is important because now we can calculate our standard deviation. Standard deviation will be P times 1 minus P, which is 0.63 divided by 100. So if we calculate that, it was like 4% or something like that. Square root of 0.37 times 0.63 divided by 100. 0.4082. So we have a mean, we have a standard deviation. Third thing we need is a shape. So we need to check large counts. In other words, can we use a normal model here? So NP, which would be 100 times 0.37, is 37, which is greater than or equal to 10. And N times 1 minus P, which would be 100 times 0.63, is 63, which is greater than or equal to 10. So our large counts are greater than or equal to 10. So a normal approximation can be used. Or the sampling distribution is approximately normal. Or I'm going to use a normal model. In other words, how are we going to calculate this with a normal model? Our normal model looks like this. The mean is 0.37. Standard deviation is 0.0482. That's the standard deviation of this normal model. And we're looking for 0.3 or less. So that's the normal model calculation we are going to do. So lower would be a really small number, like 0 or a negative. That's my upper, that's my mean, and that's my standard deviation. And remember that when you do this on a calculator, assuming that you do, you need to label everything. So I'm going to use normal CDF. My lower, since these are proportions, 0 is fine, but any negative value is okay too. These are proportions. We know that we can't go below 0. Upper is 0.3. The mean is 0.37. Standard deviation is 0.0482. And if you do that, it was around 7%. So let me see. 0.3. 0.37, 0.0482. Yep, this came out to 0.0732. Okay, but that's where it came from. Came from a normal model. Conditions were met, which allowed us to use a normal model with 37% as the mean and 4.82% as the standard deviation. So part B said, would you be surprised if 50 people in the sample said that they were stressed? Okay, 50 people in the sample, since the sample is 100, is 0.5, it's 50%. Is 0.5 surprising? Take a look at this model. 0.5 is out here. Is it surprising? Is that an unusual value on this normal model? Remember, the standard deviation's about 5%. So is this unusual? Okay, you can't just say 50 is a lot bigger than 37. I think it's unusual. You need some statistics to back you up. So two different ways you could say it. You can calculate the z-score. How many standard deviations away are we? It was like 2.6 standard deviations. Anything more than 2 standard deviations is pretty surprising. So you could say, yes, it's surprising. The z-score is 2.6. There's more than 2 standard deviations away from the mean. Or you could actually find that percent. So you could do normal CDF, find this area right here, and it came out to like 0.006 or something like that. Very, very small percent. So you could say, yes, it's surprising because only 0.0006 or whatever it was occurs at 0.5 or higher. So I'll show you. If we do normal CDF, and I put that at 0.5 and then a big number, say 0.00349. So that is 0.35% chance of 50 people or more in the sample saying that they are stressed. So yes, it is very unusual and surprising. Okay, the last or next question was about the ACT score. So on the ACT score, it says the average composite ACT score for California took the test in 2019 was 22.6. Assume that the standard deviation is 1.07 in a random sample of 45 students. What's the probability of a sample mean having 23 or more? Okay, and I know we're kind of running short on time here, but through our conditions. Said sample was random, so we have randomization. Okay, n equals 45 is less than 10% of all students took the ACT in 2019. Large counts. It's not proportions. This is means. So for means, all we got to say is 45 is bigger than 30. Remember, for sample means, your sample is large enough if it's bigger than 30. We're going to do a lot more with means in the next unit. So this is going to come back. But the important thing here is this is more than 30. Standard deviation. We're going to use a mean of 22.6 because of randomization. But our standard deviation for our normal model is sigma divided by the square root of n. A lot of you did not divide by the square root of n and you used this as your standard deviation. So this is going to be 1.07 divided by the square root of 45. So in other words, the variability decreases because we have a sample of 45. This is the standard deviation of one person at a time. This here, 0.1595, is the standard deviation of a sample of 45 people. There is less variability, quite a bit less. You're going to get completely different answers if you use this as your standard deviation compared to that. And then you do normal CDF because now we know it's normal because that number is bigger than 30. And our normal model is going to look like this, 22.6 in the middle, 23 is over here with a standard deviation of 0.1595, very small standard deviation. So this value is very unusual. 0.4 above that, but the standard deviation is only like 0.16. So this was a very low probability. It was like 0.006. I think that's where I'm getting that value. Okay, so we are done for today, obviously. Okay. So you guys, I will see you in class on Tuesday. I'll see you online tomorrow. So I will be here and our internet should hopefully be working.
I won't be here on Tuesday, so is there a day that I can make it?